Hello, this is CS4621 PPA1 WebGL Ray. This is the reference solution to the programming assignment, and in this video, we'd like to show you what it can do and what you should implement in your solution. The first thing that you'll notice in this web page is that there's a canvas, and you see a triangle over here. This canvas is supposed to implement a ray tracer, and the triangle that you see over here is not drawn by WebGL graphics pipeline or anything like that. We use the fragment shader to implement a ray tracer to actually show you this triangle. In this assignment, there are 3 scenes that you can render, and right now you're seeing the triangle scene, which contains this single triangle. There's the box scene, which looks like this. Sorry, there's the cube scene, not the box scene. And then there's the full scene with a plane, a bunny, and a box. So each of the scene can be rendered in 4 different modes. And what you see here is the face color mode, where we just output the color of the triangles. Another mode is the normal mode, where you can see the colors representing the normal vectors at each of the points. The next mode is the shadow mode, where a pixel is either white or black. So in the scene, there's a light source, and a pixel is white if the shadow ray you trace from this point to the light source is not occluded, and the point is black if the shadow ray is occluded by other geometry. And the last mode is the full shading mode, which basically takes the triangle color, the light energy from the light source, and the visibility factor you get from tracing shadow rays and combine them in a diffuse shading model. So now you can see that the light can be shadowed, and there's a gradation of brightness. When it's nearer to the light source, it's brighter, and when it's further from the light source, it's dimmer. So this is the cube scene under the full shading mode, and the triangle scene looks like this, and it's a little different from the face color. So the actual shading is actually dimmer. Besides changing the scene and changing the render mode, you can also change the camera setting. You can change where the camera is looking at, and as you change the value, you can see the update being reflected on the canvas in real time. You can also change where the camera is looking at. You can also type the values in. So for example, that. Or change the camera up vector. You can also change the field of view, and the field of view is just basically the zoom level. High field of view means it's zoomed out, and low field of view means it's zoomed in close. If you change the scene to another scene and back to the scene you were working with before, the default configuration is restored. And now we are back at the beginning configuration. You can also control the light source in the scene, and you can change its position. And as you update the position of the light source, you see that the shadow and the shading of the object changes in real time. You can also change the light intensity. For example, I can change the color so that the light is red instead of white. Or I can change the intensity so that it becomes a dimmer white light. In the write-up, there's also a specification for the background color, and this is the color that you're supposed to assign to a pixel if the ray associated with that pixel doesn't hit any geometry. Right now, the background color is black, but I can change it to green or yellow. So in your solution, please make this feature happens as well. So this has been the reference solution to PPA1, and I wish you good luck in the implementation and have fun with the programming assignment. I'll see you around. Thank you.